let's go to page 87, and this is lesson 2.3. This lesson is about applying the deductive reasoning. Okay, so deductive reasoning use facts, definition, accepted properties, and laws of logic to form a logical arguments. This is different from the inductive reasoning, which use specific examples and a pattern to form a conjecture. So deductive reasoning use facts, mostly just use facts, whereas inductive reasoning using the pattern. Okay, so that's kind of the main distinction between the two. Okay, so now let's go ahead and look at the key concept, the law of logic. The first is a law of detachment. Okay, if the hypothesis of a true conditional statement is true, then the conclusion is also true. And so here's like the pattern. And so it's, if this is true, then this is true. And if this is true, okay, so if this is true, then this is also true. So think of it as like a chain link. Okay. So again, so if this is true and this causes this to be true, and because this is true, it will cause this true. Okay. And therefore you can do it's almost like a substitution. Think of like in algebra, it's like a substitution. So think of like if P equal to Q and Q equal to R, then P equal to R. Okay? So this is like think of it like a substitution in algebra. Okay. So let's go to example 1. It says use a law of detachment. It says use a law of detachment to make a valid conclusion in a true situation. If two segments have the same length, then they are congruent. You know that. So here's your statement, right? And now they give you this. You know that BC equal to XY. So that is this one here. Okay? So since this is this, then we can conclude that they are congruent. So we can conclude that segment BC is congruent to XY. So again, let's read through this. Because BC equal to XY satisfy the hypothesis. So again, this satisfy the hypothesis, a true statement. The conclusion is also true, so that the BC is congruent to XY. Okay. So again, if this is true, it causes this to be true. Okay. Okay, now let's go to B. Okay, Mary goes to the movie every Friday and Saturday night. Okay, so again, that is your the true statement. That's your hypothesis. And it says today is Friday. So based on these two facts, you can conclude that Mary will go to movie tonight. Okay, so again, first identify the hypothesis and the conclusion of the first statement. Okay, the hypothesis is if it is Friday or Saturday night. The conclusion is that Mary goes to the movie. Okay, so today is Friday, satisfy the hypothesis of the conditional statement. So you can conclude that Mary will go to the movie tonight. So this is the law of detachment by just matching up and think of like a substitution, okay, in algebra. So if this is true, then this would be true, okay, and from there you can find your conclusion. Okay, so again they give you the statement and they give you the hypothesis and you can come up with a conclusion. Okay. So again the law of detachment, okay, they give you a true statement. Then they give you the condition, the hypothesis. Then based on the condition they give you and the hypothesis, you have to come up with a correct conclusion. Okay. Now let's go to the next one. So this is on page 88, and this says use the law of syllogism. Okay. This is almost like, think of this as like playing the domino game. You try to match up the numbers, okay? So it says, if possible, use the law of syllogism to write a new conditional statement that follow from the pair of true statements. Remember, think about the game of domino. You try to match things up, okay? Try to line up the things that match. Okay. I'm going to do this one because I'm going to do the B first. Because it's easier to see. Okay, so if x squared is greater than 25, then x squared is greater than 20. It says if x is greater than 5, then x squared is greater than 25. So what can you conclude about these two? Now again, remember what I said, right? Think about the game of dominoes, right? So notice you got x squared greater than 25, x squared greater than 25, right? So you can try to line these things up, okay? So by lining it up, okay, then you can, so lining up, so this is going to be the beginning, right? So this is going to be the beginning, that's the middle, and the end, right? So that means we can, so this beginning would be your hypothesis, the end would be your conclusion, and the middle, once you line it up, once you link it up, then it doesn't matter, okay? So again, think about the game domino, the domino games, okay? So the things that are same, you match it up, okay? So that become the middle, and so this would become the beginning because this is in front of the middle, right? And this is the end because this is up to the middle. So by link it up, then your conclusion would be if x greater than 5, then x squared would be greater than 20. Okay? So again, that's the law of syllogism. Okay? Think of it as playing the game of dominoes. Okay? So here, see? Okay? So that's how you can conclude, right? So you can just look for the part that they are the same, and that's how you link it up. Okay? Just like in the game of domino, you try to match up the numbers. Okay? Okay, now let's go back to this one. If Rick takes chemistry this year, then Jesse would be Rick's lab partner. If Jesse is Rick's partner, so again, see that lab partner, so this matches up. Okay, now since this comes before these, so this is your beginning. It says then Rick will get an A in chemistry. So you can look for the common part. So lab partner, so that match up. Okay, so the part that match would be the middle. Now, since this comes before the middle, so this would be a beginning. Since this comes after the middle, so this would be the end. So since this is the beginning, this would be your hypothesis. This is the end, so this would be your conclusion. So that means it becomes if Rick tests chemistry this year, then Rick will get an A in chemistry. Okay, and that's how you do this. Okay, so you can look for the common part and link it up, and there will be your middle. And you can figure out what's the beginning, by see what's before and what's the end, and there will be the conclusion. Now let's do C. If a polygon is regular, then all the angles in the interior of the polygon are congruent. Okay, and it says if a polygon is regular, then all its sides are congruent. Okay, so again, see the regular, so this links up. Now in this case, since both come after that, then it doesn't matter. You can decide which one you want to write. You want to come first. Okay, so you can say if all angles in the interior of polygons are congruent, then all its sides are congruent. Okay, or you can do if all the sides of a polygons are congruent, then all the angles in the interior of the polygons are congruent. So you can do either way. Okay? But remember, when you do that, sometimes you can, but when you do that, right, in this case, it doesn't work, right? Why? Because if you look at it, it says neither statement conclusion is the same as the other statement. So even you can write it, but it does not equal to what is, like original. Okay, because like this over here, you don't know which cause which, right? Okay. It says neither statement conclusion is the same as the other statement's hypothesis. You cannot use the law of syllogism to write a new conditional statement. So you cannot use this for this one. Okay, even when you try it, it doesn't work like this one here. Okay, it's not like a one way to, because you can do it either way. Okay, in this case, you can make this the first, or you can make this the second. Okay, so it doesn't kind of it tells you exactly the order that it's supposed to be. Okay, whereas over here it's very obvious, right? You can link it up. Okay, just like domino. In this one you cannot, because this one is matched, but see both come after it, right? Okay, so in this case, if you write it, you still can write the if statement, but it may not, be true, or it may not be logical. Okay, so just be careful with that. Okay, so again, you can write it based on just these two that link it up, but it doesn't work like the first two, because the first two is very clear. what is the cause, what is the effect, what is the beginning, what is the end. But this one is not, okay, because this link up like that. Okay, so even you write it, by putting this first or putting this first, but again, it may not work out because it may not be true. So just be careful with that. Okay, let's go to example 3. Okay, it says use inductive and deductive reasoning. Okay, so what conclusion can you make about product of an even integer and any other integer? So remember, inductive reasoning is you just using the pattern, right? Whereas deductive reasoning, you're using the fact. Okay. So look for pattern in the several examples. Use inductive reasoning to make a conjecture. So you can try a whole bunch of different examples. So -2 times 2 equal to -4, -1 times 2 equal to -2, 2 times 2 equal to 4, 3 times 2 equal to 6. So you can try a whole bunch of examples. So conjecture is, by looking at all this pattern, you can say that even integer times any integer is equal to even integer. Okay. So again, if you have even integer times any integer, it gives you even. Okay. Now, so that's kind of the inductive by looking at the pattern. But again, be careful with the inductive, okay? Because sometimes you may get tricked and then you come with a wrong conclusion, okay? Because sometimes the pattern you see looks true, but if you go even keep going the pattern, it may come up to a point where it's not true anymore. So just be aware of that. Okay. Now let's go and use deductive reasoning. It says let n and m each be any integer. Okay, use deductive reasoning to show the conjecture is true. So again, you pick a number and multiply by 2. Okay, so whatever number you have, you multiply by 2, then would be an even integer. So 2n is an even integer because any integer multiplied by 2 is an even. Okay, so now we're going to treat this as like your x. Okay, that's your first number. So this is an even number. Okay, so now you have even number. So 2n is like your x, your even number. So even number times any number, okay, becomes 2nm, right? Well, then by looking at that, you know that this is divisible by 2 because there's a 2. So we can see that an even number, which is 2n, right? This is an even number times any number is divisible by 2 or even integer. Okay, so you can see that the product of an even integer and any integer is an even integer. Okay, so again, the product of even integer, that's 2n, right? 2n, that's your even integer, times any integer, the m is an even integer because there's a 2 in front. So the product is always divisible by 2. Okay. Okay, let's go to example 4. Okay, example 4, reasoning from a graph. Tell whether the statement is the result of an inductive reasoning or deductive reasoning. Explain in your choice. Okay, so A, so here's a graph, the number of strokes and the maximum depth. Okay, so the north elephant seal requires more stroke to surface the deeper it dives. Okay, so look at over here, see the pattern. So the more it dives, the more number of stroke it takes to surface. Okay, now notice this is just based on the pattern, right? Because see that the more deep, the more stroke. The more deep, more strokes. The more deep, the more stroke. The more deep, the more stroke. Right? So this is based on the pattern. So A is an inductive reasoning. Okay, so A is inductive reasoning because it's based on the pattern in the data. Okay, by looking at the pattern, again, the deeper it goes, the more stroke it takes to get up, right? See that? So that's the pattern. Okay. Whereas B is based on a fact, okay, based on what is the specific fact. So it says the northern elephant seal used more strokes to surface from 250 meters than from 60 meters. Okay. Now this is deductive reasoning because it's based on fact. Because at 250, okay, at 250, it will take about 400 strokes. Whereas 60, it take about 100 strokes, okay, from the graph. Okay, so B, deductive reasoning, because you are comparing values they are giving on the graph. So you compare the value. So you are based on the facts, based on numbers, whereas inductive reasoning is based on pattern.